Okay, so we're going to continue on in module number 1. So the last time we were together, we started on looking at chapter 4, which is the second part of module 1. So I'm going to peek in here. I'm going to pull up our PowerPoint presentation and just kind of do a brief little, not really an overview, but just kind of remembering what we had done last week, Friday. So this was chapter 4. So 2 chapters in module 1, chapter 1. Truly introduction and kind of getting our feet wet with creating kinematic diagrams. But here in chapter 4, we're now going to continue doing kinematic diagrams, but now we're going to have dimensions and we're going to move things around. So our focus is on displacements, okay? We looked at kinematic analysis, we looked at position, displacement, and we did a couple examples, graphical analysis only, where we set up the kinematic diagram, and then we moved the crank a certain amount, and then we determined where the other links that were connected had now new positions based on that location. So we did example 4.1, we did example 4.2, and that's where we left off, okay? So now we're ready to start looking at section 4.7, which is titled Limiting Positions, Graphical Analysis. As I told you the last time we were together, we are going to focus solely on graphical analysis in this class, just because we don't have time to go through both, okay? So we've got 8 weeks, and to me, you guys get a lot of math in a lot of different places. So, sorry, I'm just writing down our latest admittance. And so I feel like this is a good place that we can just focus on the graphical analysis. And it's kind of fun to get back into using AutoCAD and drawing things and seeing graphically how things come out. So when we talk about limiting positions, limiting positions is going to be when we place the mechanism output so that the follower links are in what we call their extreme position. So an extreme position is like the furthest out and the closest in. So so when we go around with our crank a full revolution, where, you know, the rest of our mechanism is going to move around. So what is the extent of its movement? So we want to know what is the stroke if we're dealing with things that are linear, or what is the throw if we're looking at things that have angular displacement, okay? So if we go to our first example is going to be example 4.6. This is found on page 88. So if we go into our book and we scooch down here a little bit, here's 4.6. And 4.6, so just kind of expecting everybody to be following along, if you don't mind. All right. So we're on page 88 in our book. This is a mechanism for reciprocating saber saw. We want to determine the configuration that sets the blade in its limiting position. So when we talk about that, you'll notice here's our configuration. This blade is going to move up and down. We want to know, based on this mechanism right here, where is the furthest point that our slider is going to go down, blade, because it's a linear motion, and the furthest point up along its line of action that it's going to be. So our first step is going to be drawing this kinematic diagram in the basic form that it's at, okay? And then what we're going to do is we're going to move it into additional 2 positions. So our job number 1 is going to be putting it into kinematic diagram form as we see it right here, calculating the mobility. So how many degrees of freedom do we have? And then we're going to be taking that next step in figuring out the limiting positions. So, so go ahead. I'm going to keep this up. We have some dimensions here. Now, this time we're going to be drawing it to scale. So you want to show the offset from the center of the flywheel here that our connecting rod is connected to. You want to show that offset by 1 inch. You will notice that we don't have an angle that this link is at. So just put it at kind of a regular angle. It's really just there to create the kinematic diagram. And then we'll actually, you know, move from there. So I'm going to open up AutoCAD. I'm not going to step by step this one. I'll just do it in the background here. But so I'll let you draw yours as well. Chris, I know you just entered, we're looking at example 4.6. It's on page 88 and we're drawing the kinematic diagram for the saber saw there. So I'm just letting everybody do it independently and I'm doing it here in the background as well. And I have to, I'll end up having to move these labels around, but for right now, I'm gonna put those there. Just anticipating that we're gonna be adding 2 more positions on here, so I'll let you guys finish up. I'm not adding any points of interest, I'm just doing a standard slider with the links. So I'll give you another minute or 2 to get things in place, and then we will we'll move on from here. Again, Chris, I'm not doing the point of interest on here at all. I'm just representing it as a slider. As the designer, you absolutely could do that. And that's where, you know, depending on the information that you know about, like whatever the mechanism is, the place that it's going to be fitting into, if indeed that's part of what you want to know or want to make sure that you don't interfere with, then yes, add those. But I'm going to kind of keep it simple for this case. And they also did, if you look on page 89 in the book, this is the kinematic diagram that they worked with. Okay. So they just made it as a simple slider. And again, that would be up to you as the designer, as the discretion, if you would add that. I would never take points off for that. Okay. That's just actually adding more information to, I don't know, have more details on it. It's fine. Okay. Is anybody still working on their kinematic diagram? Okay. Then the next thing that we're going to do before we move to the next step in CAD, we want to calculate or determine the degrees of freedom that are here. Okay. So I'm gonna bounce back to my AutoCAD. And we are going to determine the degrees of freedom. So do you guys remember sample 4.6? Do you guys remember the equation for the degrees of freedom? It's F is equal to in the room, I'm hearing it. So 3, actually, I should be underneath my camera here. In the room, so it's going to be F is equal to 3 times N minus 1, right? Minus 2 times JP. So remember, N is the number of links, okay? JP is the number of primary joints, okay? Primary joints. There was higher order joints, which are going to reflect on things like gears or cams, but we'll be talking about gears and cams in an actual module later on in this class. So we're not going to deal with gears and cams in these earlier modules. So we're just going to be worrying about primary joints. So you can just stop the equation there because we would always be doing a -0 for the other ones. Thank you, Lex. Yep, you got it. So we're going to be filling those in. So F is equal to, if I go over to AutoCAD, the number of links I have here are the numbers with the circles, right? So my highest number with the circle around it is 4. So I'm going to be putting in, oopsie, I'm going to be putting in 4, 3 times 4 minus 1 for the number of my links, minus 2 times the primary joints. If I go back over here, A, B, C, and don't forget D. D is a primary joint. A sliding joint is a primary joint. So that's going to be times 4. So if we do the math here, this is going to be 9 minus 8. So F is equal to 1. Okay. And what that means to me is I only have to do one thing in order to get this mechanism to go through its full range of motion. Okay. And that thing that I'm going to move is going to be my crank in this case. Okay. So we're going to go back over here. The crank is number 2. All right. So we've got our degrees of freedom and we have our kinematic diagram done. Now what we want to do is we want to put this in the limiting positions. Now there are 2 equations for limiting positions. You go back over here. The 2 equations are, the first one is for the furthest extreme position, and we are going to use the lengths of link number 2 and link number 3, and we're going to add them together. And we're going to see how we can get that furthest position away. And then the nearest extreme position is going to be link number 3 minus the length of link number 2. Okay, so let's do the first one, L2 plus L3. So if we go back to our diagram, you will notice, and oh, I want to point something out. When we talk about L2 and L3, we are now going to be going forward on a 4-bar mechanism. We are always going to have link number 1 as our frame. Link number 2 is going to be our crank, always from now on. Link number 3 is going to be the connecting rod. And link number 4 is going to be the output. So in this case, it's a slider, but it could also be another oscillating link if we wanted it, if we needed it to. There's those configurations as well. So link number 1 is the frame. Number 2 is the crank or the input. Number 3 is going to be our connecting rod. And number 4 is going to be our output. In this case, it's a slider. Okay. So whenever we refer to then anything with any of the links, 2 is going to be the crank, 3 is going to be our connecting rod. So that's what they're referring to these links. Okay. So it's no longer arbitrary anymore. It's going to be 1, 2, 3, and 4, as we had talked about. All right. Since we have that, now we're going to go back underneath here. And we know that the length of link number 2, which is our which is our driver right here, is going to be 0.5. Okay. So that's the length of link number 2. And then the length of link number 3, it's our connecting rod here, is 1.75. So if we add those 2 together, half inch plus 1.75, what do we get? 2.25, right? So we're going to go over to AutoCAD here, and we are going to go from the center of where link number 2 is connected, and we are going to create a radius. So I am going to actually change. This is going to be my second position of my mechanism. So I'm going to go to Object to Layer. I'm going to do a circle radius, and then my center is going to be at the center of rotation for link number 2. And now this radius is going to be that 2.25. Okay, 2.25. And I'm going to find where it intersects with the path that our slider is going to take. You'll notice that I have an intersection right down here. So I did add a line going vertical through the center, and I just put it on the notes layer just because it's just a path of its line of action, and I just want to know where it crosses. So what that means is that my furthest position away is going to be right down here, because if I draw a line so that I am in line all the way to this point, what that means is I am taking my link number 2 and my link number 3, and they're going to be extended to their furthest position where they intersect with the line of action of that slider. So now what I'm going to do is I'm going to move my slider down to this position. So I'm going to do a copy because I want to leave the original there. I'm going to grab this and then also the letter C and the connector. Enter. I'm going to go from that center down to the intersection right here. Okay. And now that's my new position. I'm going to change this to Object to Layer so that we can see that that's the new position. And then I'm going to change my C to C prime, because this is now a new position for that point C, that joint that we had. Okay. Now, additionally, I have to show where link number 2 ends. Now, link number 2, if you remember, was a 1/2 inch, and I'm just going to use this right here. It was a 1/2 inch radius. So I'm going to take and I'm going to copy my link right here from the center here to this intersection, because now this little part right here is going to be link number 2 in its new position. And then I need to copy the letter B down here because this is B prime. This is its new place. I am going to I'm going to erase this radius on the outside. And so what you can see here, and I'm also going to do that same thing for this one. So what you see here is you see link number 2, its endpoint is B. So this is its new position, B prime. And then extended in line with link number 3, and its new position now is C prime. I am not going to relabel the links in this new position only because it's going to get too crowded, okay, with all these different callouts. So the only thing that I'm going to move are the links themselves and the callout of the new points. So B moved, so this is B prime, and C moved, and this is C prime. So this is what we would call the furthest extreme position, FEP, if you would. And this is link number 2 plus link number 3, and it's its radius from the center of rotation where it intersects with the path that slider is going to take. Okay. Any questions on that right now? The furthest extreme position for this mechanism. Link 2, the length of link number 2 plus the length of link number 3. Okay, now let's do the nearest position. So if we go, is there ever a scenario where link number 2 is longer? No, that is one of the constraints that we have on this. Yeah. So now we are going to go back to our PowerPoint where we have L3 minus L2 is going to be for the nearest. So now, and this is why, Chris, we can't have L2 longer, because for this to work out, we would get a negative value here otherwise. Okay. So, so in this case, our L2, we're going to subtract from the length of L3. So if we go back underneath, our L2 is a 1/2 inch, and we're going to subtract that from the length of L3, which is 1.75. So what's that number? 1.75 minus a half inch? 1.25, exactly. So now that's going to be our new radius that we're going to do. Now, because we have a third position coming, we're going to add another layer here. And you know what I didn't do? I didn't do a file save as. If you haven't done it yet, save this as example 4.6. Okay. Let's see. Yeah, well, I don't always forget it, but it's not hard to forget to do that. And then I'm going to go to my layers and I'm going to add an object 3. Okay. And I'm going to change the color. I'm going to keep the line type and the line weight the same, but I'm going to change the color to cyan. And now I've got a new layer. So I'm going to grab and I'm going to go on my object line layer 3. Try to make it, well, I'm going to insist that you make it something that I can see. If you're using a dark background, I'm going to tell you one of the colors that I cannot see on a dark background is this blue right here, like the standard blue. Don't use that for any text or any lines. The brighter ones here work much better. Even the magenta is really good. So because if I can't see it, I can't give you points for it. All right, so now what we're going to do is we're going to make that radius this time, circle radius, and it's going to start from our point A, the center here. And that radius is going to be 1.25. Okay. And now you're going to notice, if I go here, it crosses higher than the original position, and it's going to cross the intersection is going to be right here. So now the new position for C prime prime is going to be at this intersection. So I'm going to copy my slider, the link, and C, enter. And we're going to go from this point right here to the intersection just above. I'm going to change my line to the layer object 3. I've got to move number 4 here. And C needs to go to C prime prime because this is the second new position that we have. And then what we're going to have is we need to put the line back to A. So our line is going to go from that intersection to the center. Okay. Now that represents link number 3, or the top of link number 3. Now what we're going to do is we're going to add the radius of 0.5 back in. And then we're going to extend. So if you go under trim, it's extend. I'm going to extend this line to that radius. There we go. Okay. And then I'm going to copy over the link designation for B. Put that over here. And this is going to be B prime prime. The second place that B is going to be. Let me get rid of this radius here. I'm going to move my A. Now, when you hand in, okay, when you hand in, I don't want to see any of your construction circles, okay? And I want to be able to make sense of the labels you have. So do not have anything overlapping your labels. So for instance, if I've been moving my designation for link number 4 around, okay? If you move something and something overlaps, move it so that it makes sense of where it's at, okay? So I don't want to see anything overlapping. I don't want to see the construction that you do. So an example of what I want to see is what I see right here. And actually I would probably, that line of action, you could either get rid of it or, trim it away if you want to. I think I'm just going to get rid of it because we can see it's along that line. There we go. Now, in this example, we have now our blade slider at its highest position, its nearest extreme position, which is up here by C prime prime. And then the lowest position here is going to be the C prime. That's going to be its furthest extreme position. Now, typically what we want to know is what is the difference between those high and low places? That is what we call the stroke, the full, if you would, travel of that output link, which is our slider, or in this case, it's the saber saw blade. So we're going to add one more thing. We're going to add a dimension. So you want to go on your notes line. You're going to go on the linear dimension here. I'm just going to zoom in, and I want to get the center of the top to the center of the bottom. And then I want to dimension that. Now, again, notice I went over my C, so I've got to move my C prime prime. And I've got to move my C prime so that they don't have those over the top of them. And I think I'm going to move 3 up a little bit. And then I'm going to move D maybe here. Okay. I know it's a little bit, it's a little crowded, but that's okay. And you can see that if I would keep putting my 2s and my 3s in the new positions, there wouldn't be any room for it. So that's why we only label them on the originals. Okay, so now if we look at the book answer, oopsie, wrong one, camera. If we go over on the right-hand side, they took a screenshot of, what they created in CAD. You'll notice that they didn't change the line types, which is okay, but they did use the designations of B prime and C prime, or B prime prime and C prime prime. But notice that here they have the difference between the high and the low position. Their number is 1.2656. And if we go back to ours, look at that. Ours is, if you did it correctly, you should be getting 1.2656 as well. And that's going to be the total stroke. Now, for this example, we can get rid of that designation there. You want to label this as example 4-6. So I'm just going to add multi-line here. Example 4-6. And then you would also want to either here in AutoCAD, if you want to write out the calculation for mobility and add it to your screenshot here, or if you want to just take, a picture or a scan of the calculation, if you did it by hand, you can do it that way as well. But I do want to see both the kinematic diagram in its standard form with the 2 extreme positions, the stroke dimensioned, okay, and your mobility equations for this practice problem. So any questions about this? And this would then also be how you would hand in a problem like this for your homework, which you do have one that's very similar. Okay. All right, I'm going to do a quick save on this example. My M2 do not reach the slider. You got to check your dimensions then. So, so you've got to go back and look. Probably one of the dimensions you might not have done is this is an offset of 1. The extreme position equations they're just simply, the extreme position equations are these right here. It's just adding or subtracting the length of the links. I'm not having you guys write those out. It's easy to just add and subtract those. The mobility equation is your F is equal to. Does that answer that? Okay. And then Lex, yeah, check your dimensions because they should be coming out. A new message down here. Okay, yes. Yeah. Any other questions? All right. Then we are going to go to our next example. So if I go back over here, did this one, we're going to look at our next example, which is going to be 4-7. Okay. So I'm going to go underneath again, turn the page. 4-7 is found at the top of page 90. Okay. And here we're going to draw the kinematic diagram and show the limiting positions of the automatic car wash nozzle mechanism that we see here. So you'll notice that we have a motor. Connected to the motor is going to be, this is going to be our crank link, okay? Our connecting rod. And then this is going to be the nozzle itself. So this is our output. And what we want to know is, as this sweeps through, what is its highest position and what is its lowest position? Now, this time, this is not a slider. This is going to be a link that oscillates, okay? And we would want to know what that extreme position would be so that we can measure what is the angle between its highest and its lowest points. Now, that's not called stroke. That instead is called the throw of the mechanism, okay? So throw is going to be an angular displacement. So we're going to measure the angle between how high this goes and how low this goes, all right? And then we would then compare that to, you know, wherever we're coming through with our cars, and the highest and the shortest cars that we're expecting to come through our car wash, and see if that angle is gonna work. So first things first, we're going to draw the kinematic diagram for this mechanism. Now, if you needed to or wanted to, the down lower on the page 90, they do show the kinematic diagram. So if you wanted to peek ahead, or if you wanted to just do it from the illustration, use the dimensions that you see here to create it. So I'm going to do that in the background here. So I'm going to open up a new start file and then rename it to this new example. And let's save as example 4_7. Okay. So I'm going to move this over here. Here. Now here again, I'm going to choose not to do the extreme position. There is a little bit of an extension outside of the nozzle. If, as the designer, you would find that to be something that you feel would be important, you certainly could add that, but it doesn't seem to be terribly extended. So I'm just gonna stop it at the joint. Lex, did yours work out? Hopefully you found a dimension that maybe you didn't have. Just checking in. Otherwise, I can help you when we're done with this one. We'll be taking a break after this one. Oh, you had it drawn as 1.3. Yeah, and it needs to. Okay. All right. Good. Good, good, good. I'm glad. All right. Does anybody need extra time to work on their kinematic diagram, the first version here? All right. Okay. If not, what we're going to do is we have this now, and if you would, it's home position. It's just a random somewhere around the, the circle of the crank, and it's just a random spot. So now I'm going to go back underneath here. We are going to be putting this in. Oh, no, I have to back up. I don't always forget, but we also want to calculate our mobility quick. Make sure that our mobility comes out to 1, because that's a confirmation that we have our links and our joints labeled appropriately. So I'm going to go underneath here, zoom out just a little bit. This is going to be example 4.7. So you're going to want to either put this on the CAD drawing or hand draw it, but you'll need to include it. So F is equal to 3 times N minus 1 minus 2 JP. Remember, we always want to write it in a variable form first. So this is going to be 3 times the number of links. As we look at our kinematic diagram, number 4 is our largest number. So it's going to be 4 minus 1 minus 2 times. And we have A through D, so that's also going to be 4. So we have our 9 minus 8. Our F is equal to 1. Okay. So again, you could also add that to the file here if you found that to be more convenient. Okay, so we've got our mobility, we've got our kinematic diagram. Now we're ready to determine our extreme positions. So L2 and L3, remember, this is the length of link number 2, which is our crank, plus the length of link number 3, which is our connecting rod. So going back underneath our camera, if we look at the dimensions we were given, the length of our crank is 0.75 and the length of our connecting rod is 2 inches. So simply adding those two together, we're going to get a length of 2.75. So that means that this link and this link will be extended, okay, outward. So we are going to go from the center of A. I'm going to switch over to object B, and we're going to draw a radius, a circle radius with a radius of 2.75. Okay. Now it has to intersect with something. As we know, C is on the endpoint here, and this link right here, we want to know like where that's going to intersect. So we're going to draw another circle radius, and its center is going to be at the center of D, and its radius is going to be the radius of 2, or why is that not to the right spot? It should be exactly 2. Why am I off? Hold on. Hold on. Let me do an aligned dimension here from here to here. Oh, why is that not 2? Okay, I've got to redraw my kinematic diagram here. Let me check this one. Is this one 2? Yeah, that one is. Okay. So sorry, I'm going to just go back and make this correct because I'm not going to get the right value in the end. And it is important that we get the right value. So then 2, there we go. So here to here to here, there we go. So now I can get rid of this. And I'm going to change this to my object 2 here. And then I'm going to Copy this over here to here. There we go. Okay, now we're in the right position. So, so this is the path that our link 4 or our endpoint of C is going to take. So where it intersects with our radius from A when link 2 and link 3 are in line with one another is going to be down here. So we're going to copy that joint and the designation of C, and we're going to put it down here. I'm going to double click that, and that is going to be C prime, okay? And then we are going to draw a line from here, from A all the way down to C, okay? And that is going to represent the length of link 2 plus link 3. So to show where link 2 is, 7, 5, I'm going to copy the joint B and the designation for B down to this intersection right here. I'm going to move this B right there, and that is going to be B prime. Okay. I'm going to get rid of this one and that one. I'm going to leave this one in here for right now. I'm actually going to change that to the notes layer just so it's not so big. So this is link number 2, see, and link number 3. So the endpoint is B prime and C prime. Now to connect it back to D, I'm simply going to draw a line to represent link number 4 in its furthest extreme position. Okay, because it rotates around B and it is going to then follow this arc for its line of action, if you would. Okay. So any questions on this right now for the extreme furthest position? Okay, now we've got to do the nearest extreme position. So if we look back, that length is going to be L3 minus L2. So we are going to look back underneath here. Our L3 is our connecting rod, 2 minus 0.75. What would that distance be? What would that radius be? 1.25. So we're going to need an extra layer. So we're going to add an object 3 here. I'm going to make it that cyan color again. Okay. And now I'm going to change it to that cyan color. And I'm going to draw my circle with a radius of 1.25. Okay. And now where it intersects the path of C, which would be right here where they would come together, is going to be my nearest extreme position. So I'm going to draw a line from the center of A down to this intersection that I just created. Okay, right there. And that is going to be my new position for C prime prime. C prime prime. So I'm going to double click on that. That's going to be the nearest extreme position. I'm going to draw my line from C back to D right away. That way it's there. And then I need to draw B prime prime. So I am going to grab a radius, circle center at A, radius at B. And now I'm going to use that extend function again under trim. And I'm going to extend this until it gets to that outside radius. And now my new position for B prime prime is going to be over here. Okay. So I'm going to get rid of the radiuses that I don't need. Okay. And I don't need this one anymore either. And I'm going to move my label to there. And again, trying to kind of scooch them so it makes sense where things are. All right. So now what I have is I have C prime prime as its highest position that it's going to, that nozzle is going to be, and then C prime is going to be in the lowest. So this is the extent as I go around one full revolution. These are the 2 points that are the limiting positions for that nozzle. Okay. Now for the answer here, we are not going to do a linear dimension. This is an angular displacement. So this is the throw of the nozzle. So if we go back to the illustration here, this is a fixed rotation point. So this is only going to be an angular displacement. So we are not going to put a linear dimension on this. We are going to measure the throw as an angle. Okay. So if I go back to AutoCAD and I go to my notes layer, I am going to change this to an angular dimension. So I'm going to put an angular dimension and I'm going to go from the C prime prime to the C prime, and I'm going to put this angle in here. Okay. Now, there's a good chance that this is not just exactly 47 degrees. It's probably 47 point something, something, something. You need to add 3 decimal points to this angle. Okay, I will be looking for that when you hand in your practice problems. That'll let me know that you followed along. So what you're going to do is you're going to go to annotate, and we're going to go to dimension style. And we're going to change and modify this dimension style. We're going to go to the primary units tab. Okay. And then down here on the right-hand side, these are your angular dimensions. We're going to change the precision to 3 decimal places for angles. And we're going to say, okay, set current, and then close. And now your angle should be 47.008. If you did it to 2 decimal places, it'll be 0.01, but I want it to 3. Okay. Did everybody get 47.008? Yes, I've got thumbs up for 1 person in the room. Darn it. Then you have something wrong. Mine is about off by 0.5 degree. Crap. It should be 47.008. That's exactly right. Because then what's happened is you don't have things lined up quite right. So you're going to want to troubleshoot that. Yeah. Okay. So check all of your dimensions, make sure that your radiuses were correct as you did them. And you should get 47.08. Now, handing this in, you want to label this as example 4-7. Okay. You can, add a note right here. So you can just add multi-line text. Example 4.7, whatever it is. And then some way, somehow, you want to make sure that you get me your mobility mobility calculation, whether that's by hand or adding it to this, this example. What page is this on? This is on page 90, Aaliyah. Okay. All right. So that's example 4-7. I am going to stop the recording here.